Okay, so we'll start. My name's Gavin Newlands, and I'm one of the developers who works on Oasys Primer. And today I'm going to be talking about the Occupant and seat tools within Primer. So it's an introduction to all the tools that you can use to position seats and position occupants. If it's okay, we'll leave questions till the end. So this is what I'm going to be going through today. I'm going to go through the just some introductions on Oasys Primer. We'll talk about seats to start with. I think it's worth talking about seats when we're talking about dummy positioning because they're obviously linked together. We'll talk about how you can create mechanism data within Primer that can be used to position seats. Talk about how you can position seats in various different ways. Then move on to dummy positioning, the various different tools that you can use to position dummies and so on. And also looking at how you can link a seat to a dummy for combined positioning. Going on from that, we'll talk a little bit about seat foam compression, so squashing a seat. And there's two different methods of doing that in Primer. There's the Primer method and also a pre-simulation method using LS-DYNA. We'll talk about one of the newer methods for dummy positioning, which is pre-simulation dummy positioning, and you can use Primer to set up an LS-DYNA analysis to do that. And I'll just briefly touch on airbag folding at the end because it is related to the occupant related stuff that we're talking about today. So again, just a brief summary of Primer and the Oasys software. So the various packages that we produce. Primer is our preprocessor, and that's used to assemble, edit, and check models. D3plot is one of our post-processing packages for displaying and animating results. We have THIS, which is a time history plotting and processing program, and then Reporter is an automatic post-processing tool which pulls together images and graphs and so on from all the other three programs and pulls them together into standardized reports. So what's the purpose of Primer? So Primer is a specialized preprocessor, so it's used only for LS-DYNA models. So the tools and comprehensive error checking can reduce preparation and debugging time. So it's fully compatible with the latest version of LS-DYNA, so no information is lost when reading or writing out model data. It's got model management tools that allow the team to work in parallel on different components of the same model. And because of Primer's robustness and depth of understanding of the LS-DYNA data, users tend to trust Primer to work on their complex models without corrupting or losing any data. So first thing we're going to talk about is seat positioning. So to position a seat model in Primer, you need to create something called a mechanism. So a mechanism definition is something that you create in Primer and allows you to move the various components of a seat around. And a mechanism definition is made up really of three different components. So the first component is an assembly. An assembly is a grouping of parts essentially in your seat. So assemblies are identified by parts or part sets. So it could be the back, it could be parts of the rails, and it could be links and so on. And during positioning, each of those assemblies behave as if rigid when you're moving the seat around in Primer. The next component of a mechanism definition is a connection, and these are the joints that connect together the assemblies. So they're defined at nodal points or coordinates, and these are used purely for positioning the mechanism, and so they're independent of any LS-DYNA joints that you might have in your model. And the connection types are pins, hinges, and sliding joints. And then we've got the third component, which is reference points. So the H point is an example of this. And these are points in space that are linked to assemblies in your model and can be used to position your seat or constrain your seat. So here's an example of a very simple seat model where we've got the model, the seats separated into different assemblies, and you can see we've got just some representations here of some of the joints that are in there that will allow this seat to move. Sliding joint down the bottom, and then pin joint and hinge joints as well. So there are some requirements before you set up a mechanism. So you need to know which parts will be in which assemblies. So it's fairly convenient to group these into sets before you start to create your mechanism. Nodes must not be shared between assemblies, because that can cause some problems. Assembly should not contain parts of elements bridging across to other assemblies, so it'll lead to a shared node problem, and you could get deformed meshes when you start to move your seat around. And as I mentioned, the joints in the primer mechanism are independent of any LS-DYNA connections between the parts. And your seat model does not need to contain LS-DYNA joints, because in reality you might have your seat locked up in a particular position and you might not have joints in there. They might be modelled with constrained rigid bodies or nodal rigid bodies or whatever it may be. However, if your model does contain LS-DYNA joints, there is a tool in Primer available to automatically create mechanism data from a seed selection. I'll show a slide on that later on. So you've read your seat model into Primer. How do you start to create a mechanism? Well, you go to Tools, Mechanism, and then you can click on Create to create a new mechanism, or you can click on Modify to modify an existing mechanism in your model. And that brings up the panel that allows you to create the different components that I've just gone through, so assemblies, connections, and points. So the first thing you'll probably do is create all the assemblies. You'll split the seat model up and create assemblies for all the different components. So this is the assembly creation panel. So you give it a title and an appropriate label. You can specify restraints, and these are optional. You don't have to specify these, and they're used to constrain movement when dragging the assembly around. So 6 degrees of freedom, you can lock any of them. So that's applied in the global coordinate system, unless a local system is defined, and then it's defined in the local system. And the main part of this panel is specifying the parts that are in the particular assembly that you're making. So you can either specify a list of part sets. If you've already split them up into part sets, you just need to specify one part set here. Or you can add them as parts as well, or a combination of the two. Also, if you want to, you can add node sets in as well to this assembly. And this is available for adding, loose nodes that you might want to be a part of an assembly that aren't necessarily in a part that you want to include in the assembly. So for things like spot welds that span across assemblies, you can add one node from one side of the spot weld into one assembly, and one node from the other side of the spot weld into the other assembly, and things like that. So once you've created all your assemblies, you then want to create the connections between those assemblies. And there are three main types of connections. The first one is a pin. So in this case, two assemblies are connected together at a point defined by a node or coordinate. So the panel for creation, this looks like this, and it acts like a sort of Dyna spherical joint. So you've got the two assemblies, a node or a coordinate. The second type is a line, and here we've got two assemblies and 2 points. And in this case, a line joint allows assemblies 1 and 2 to slide along and rotate about the axis defined by the points, the two nodes or the two coordinates that you specify. And you can define limits for these. So up here in the panel you can see permitted positive slide, permitted negative slide, and the same for rotations and so on. There is an option here as well to add an intermediate assembly. So if you've got one assembly moving on the other, you may have an intermediate assembly between the two that moves with one of the assemblies as well. So you can specify that. The third type here is a hinge, and this is pretty similar actually. It's the same as line, but translation along the AB axis isn't permitted. So this is good for something like a seat back rotation. Here you can see the back of a seat, and we've got a line through here, and the seat back will rotate around that. Again, you can specify limits on that rotation. And a third thing you can specify in relation to a mechanism is a reference point. So an obvious one here is an H point. But mechanisms can have any number of reference points, and each may be positioned to use a specified coordinate. So you specify a reference point and you link it to an assembly. So here you can see in this panel I'm linking node 529 to assembly 3. And you can specify a point by a location as well rather than a node. If you don't have a node at a particular reference point, you can do it by an XYZ coordinate. Again, you can restrain that point, which will in turn restrain the assembly that it's connected to. But these are useful for positioning. So once you've got your seat model set up, you can specify to move the H point to a particular location, and it will move the assemblies that are attached to it. Okay, so those are the steps that you need to go through to set up a mechanism within Primer. Once you have that mechanism set up, so you've defined all those components, you can then use the positioning panel to position your seat. So the position menu allows you to move the various assemblies within the mechanism. And you can apply restraints to these assemblies. So in the example shown here, it's a very simple seat model, but you can see that I've got an assembly called fixed rails. So this is the rails right at the bottom, and so they are constrained in all translation and all rotation degrees of freedom. And there are various different modes here that allow you to move things around, and I'll demo this in Primer in a second. So probably the most useful one is the drag assemblies one that we're showing here, and this allows you to click on an assembly on the screen and pull it around into a particular position. Let me go into Primer and just show you that. So here we have a seat model, a fairly simple seat model. It's been split up into assemblies and connections have been defined. So if I just rotate it around slightly, I've got transparency turned on for the various parts in the seat so you can see all the different components. So under Tools, if I go to Mechanism and I modify this mechanism, first of all, if I look at assemblies, if I click on Edit, so I've got 8 assemblies in here, and if I hover my mouse over the entries in this list, you should see them sketched on the screen. If I just click on one of them, the seat back, you can see here that I've basically got a list of parts in this seat back. That's how it's defined. In terms of connections, if I edit those, I've got 7 connections in the model. So this bottom one here is seat to seat back hinge. If I open that, it's a hinge type. It tells me the 2 assemblies that it acts between. So it's the seat base and the seat back. And then there's 2 nodes, one on each side, that defines the axis. And that's it. I do have some rotational limits, so it can only rotate forward by 10 degrees and back by 15 degrees. but that's the whole definition. And finally, points. I think I've only got one point here, which is the H point. If I sketch that, take my model around, you'll see it's defined there and it's linked to the seat base. And in terms of restraints, I've got it restrained in the Y translational direction, so you can't move that point in the Y direction. So that's my mechanism set up. And you can modify those, and you can add more than one of those to a model, and so on. So now we want to go to position. So if I click on position, you get this panel here, and by default you'll be in the drag assemblies option. So this is where you can modify the restraints on the different assemblies and drag the seat around. Now this might not translate well over the webcast, but we will try it. So if I click on the seat base here, the model goes grey because it's a less expensive way of drawing a model. And if I move my model around, hopefully you can see all the assemblies moving in relation to each other and in relation to the connections and adhering to the connections that I've specified. So as I said, when doing this, all the different assemblies are moving as rigid bodies. Now in this model I've got the fixed base at the bottom, locked in all translation and all rotational degrees of freedom, but everything else is able to move. Now one thing that isn't able to move actually is the seat back. So if I click on the seat back, you can see that's not rotating in relation to the seat base. Now that is because if I go down to connection list, here I get a list of all my connections that are in the model, and you can specify to lock some of these connections at this point. So I've got the seat back to seat hinge locked with this tick down the bottom. So if I unlock that, I can then click on the seat back and rotate it relative to everything else. And so you can see you can go through a process of locking various assemblies, clicking on an assembly, and moving things around as you want to. Another way you can move things around in this panel is by rotate angles. Now I should say here that when you're moving things around, nothing is permanent until you click accept at the top. So if I click reject, the seat goes back to its original position and nothing's changed. So I go back into position now and go into another way of moving things around, which is rotate angles. So here you can specify angles in all the three different rotational directions of each assembly. So this is the angle relative to the original mechanism definition when you created it. So I created the mechanism definition with the seat in this position, and so everything's set to 0. So if I try and change the seat back, let's put 5 degrees in there, you can see the seat move forward by 5 degrees. In this panel as well, you can also drag the model around if you want to, and you'll see the angles change. Okay, let's go back to the slides. These are just the slides explaining what I've just talked about. So the connection list is a way of viewing all the different connections that you have in your mechanism and locking them or unlocking them. And then rotation angles are a way of moving the assemblies around by specifying particular angles of rotation. Now the final way of moving these the seat around is by using these points that you have specified. So the example I showed before, I've got one point specified, which is an H point, and you can say whether you want to move that particular H point to a particular location, or you can move it by a particular delta, or you can move it to a node. So this top point here, which is moved to a particular position, you can see I'm typing in a value here, and I put wildcard into the Y coordinate, which means I don't care what the Y coordinate is. Or this move by delta, you can specify to move it forward by 10 millimeters and up by 10 millimeters and so on. So if I just go back into Primer and go to position points, so you can see this is my H point, which is now sketched on the screen. If I wanted to move that forward by 5 millimeters, I can type in 500 and it will move forward. And because that point is connected to an assembly, so obviously it moves that assembly forward, but it takes into account all the different linkages and relationships between assembly connection, and so on, and will move everything accordingly to get to that end position. Now, you can imagine it might take, a certain amount of time to set up a mechanism and also to specify particular positions. All that information can be stored in your keyword file, and that means that when you read the model back into Primer at a later date, you don't have to set up the mechanism again. It will exist, and you don't have to do anything. You can just start using it. It also means that after you set up your mechanism, you can position the seat to various different locations and then save those as positions. And that means that when you read a model into Primer at a later date, you can very easily retrieve those positions without having to go through the positioning process again. So you might save a series of positions, mid-mid, low-mid, and so on. And that's done through the panel in Primer. If I go to Save Retrieve in the positioning panel, you have options for saving and retrieving particular positions. I'll show you what that looks like in the keyword deck in a minute. So I mentioned earlier that there is an automatic method of creating mechanisms that you can try first, and what that does is you specify a start node, so a seed node really, and then Primer will propagate out from that seed node and find assemblies by looking at groups of parts that are connected together by various different connection types. And those connection types could be joints, or maybe you define connections between assemblies with discrete elements or beams or something like that. So in this automake panel, you get various options that you can say connect via joints, for example, here, or discrete elements. You can turn those on and off and set certain things about the length of those connections and so on. So the way you work in this panel is you select a start node. In this example here, the suspension system, if you pick the node in the wheel there, in the tire, then you click on a calculate button, and Primer will do something. It will do the propagation. It will split things up into assemblies and so on. And on this panel, you get a summary of what it's done, so you can have a look through to see if it's done something sensible. You can then tweak some of the settings, change some of the settings, and try again until you get the best result. So it's often a good place to start when creating mechanisms, and then you can then tweak it later on. And what you end up is with a mechanism, so you end up with assemblies and connections and so on, and then you can restrain certain ones and start dragging your assembly around. Now, one other thing that is a component of a mechanism that you may or may not want to use is something called a stretch component. And I'll just show you in Primer where you define those. Oops. So if I'm modifying a mechanism, so we've got assemblies, connections, points. I'll explain what children are in a minute, but then you've got stretch definitions at the end. So these are other things that you can create as part of the mechanism. And these are here purely to allow you to specify parts that can be stretched during the mechanism being moved around. So here's an example of a suspension system where you've got an explicit mesh of this spring, and you want that to stretch when you are moving the wheel up or down, for example. And all you do is you specify two end nodes, so node 1 and node 2, and you specify the parts in the middle that you want to apply the stretch to. And then when you move the assembly round, Primer will calculate the change in distance between node 1 and node 2, and it will modify the mesh of the stretch part accordingly. So here's another example where you might have some springs in your seat and you're moving it around, moving components that are attached to those springs. You might want to stretch some of those parts. And this is how you define them, as I've said. So if you go to modify, here we have stretch, where you can create them. And all you really are specifying here is the parts or part sets or node sets that are the entities that you want to stretch. And then you've got node 1 and node 2, which are the two end nodes, which are used to define how something is stretched. So I mentioned that when you write out a model, it stores the mechanism data. So that is stored after star end. So you write the keyword data out. After star end, you will see keywords that begin with star mechanism start and star mechanism end. And they look like normal Dyna keywords. So you'll have assembly definitions and hinges and so on. And so they're after star end. So Dyna doesn't do anything with those, but Primer will read those back in and know what to do with them. And you'll be able to retrieve your mechanism data and your positions automatically. Okay, so that is just a brief introduction to seats and seat positioning and mechanisms and how to use them. We'll now move on to dummy positioning. So with dummy positioning, in Primer it works in a similar way to positioning using mechanisms. So in the same way that you have mechanisms split up into assemblies and those assemblies are connected together, dummies are separated into assemblies and connections are defined between those assemblies as well. Now the assembly and connection information, so that's generally called the dummy tree, is predefined by the dummy supplier and included in the post star end data. So there's no real need for you to set this data up in Primer. You can do. If you go to Safety Dummies, there's a Create and Modify panel where you can define assemblies and define joints between assemblies. But if you get dummies from Humanetics, Dynamo and so on, they will have this information predefined and will exist after star end. So when you read the model into Primer, that it should all be there and ready to go. So there are various tools in Primer for positioning in the same way you have various tools for positioning using mechanisms. And when you first read your model into Primer, it'll be in its default position. So it'll probably be positioned at 0, 0, 0. all the arms and legs will be in a standard position, and you'll want to move that to a particular desired location. So the first things you might want to do is there's a set H point where you can move the H point of the dummy to a particular location. So in the same way that mechanisms have these reference nodes, you can have reference nodes or reference positions within a dummy, and all the dummies that you'll get, they'll have a reference node which is the H point. And there's a set H point button in Primer where you can specify where you want the H point to be. There's also a global sort of rotate translate button as well, which takes the dummy and just moves it generally to a particular position. So you can set a global H point and you can set a global rotation angle as well. But the main panel for moving dummies around is under Move Parts. Now, the Move Parts panel brings up a menu. It's very similar to the mechanism positioning menu, so this will be familiar from the first part of the talk. And so the initial submenu is Rotate Angles, which is the same as we looked at in Primer. And this is the old style dummy positioning, really. So this is the thing that was first introduced into Primer. So here again, you can specify the different angles of rotation for all the different assemblies. And you can use the different mouse buttons here to do different things. So the left, middle, and right mouse buttons will rotate around the local X, Y, and Z. The next one is Drag Assembly. Again, this is very similar to the panel you saw in Mechanisms, and you use the mouse to drag the assemblies around. And assemblies can be locked in different degrees of freedom as they can with Mechanisms. So I'll just go into Primer now and show you this. So I've got a model here where I've got an occupant and a seat, steering wheel, it's a simple model. So if I go to Safety Dummies, and I go to Position, and I'm going to go to Move Parts. Just minimize the keywords so you can see the full panel there. So this is the panel. So you can see I've got 21 assemblies in this dummy model. Elbow left, elbow right, wrist left, and so on. So there's quite a few assemblies in here. And I'm in the Rotate Angles panel. So here I can specify particular rotations. So I'll do it interactively actually. So if I right click on something, you can hopefully see that I'm rotating around the local y-axis here, and there's a red box under the 8th assembly which shows how those angles are changing. Yeah. Again, as I said, you can type the values in here and, if you want to as well. So the next one was Drag Assembly, which is probably the most useful option here. So again, you have all your assemblies down the left-hand side, but then you've got all the constraints that you can apply to the different assemblies, so translation and rotational restraints. So what I want to do here is move this leg around. Now you have various options. So if I use my left mouse button on the foot here, hopefully you'll be able to see that I'm dragging the foot around, and Primer knows that the foot is attached to the lower leg, and the lower leg's attached to the upper leg, and the upper leg's attached to the pelvis, and so on. And so the whole dummy is moving according to me dragging that foot around. Now the middle mouse button and the right mouse button do different things here. So if I use the middle mouse button instead of the left mouse button, you can see I can just move the assembly that I'm clicking on. Now the right mouse button is a bit more useful actually, because if I click on that, it will move just the assembly I'm clicking on and the one that's attached to it further up the hierarchy. So I can move the foot and the leg around here. And so if I click on the lower leg with my middle mouse button, you can see I can move that around, and if I click on the upper leg, you can see I can move that around, and so on. So hopefully you can see that you can click on various assemblies at the bottom of the tree in terms of the feet and the hands, or further up, and move things around in a natural way. You can see here that I've got my hands and feet. If I lock my hands and feet in position, a common thing you could do is move the occupant around while your hands and feet are locked, maybe to a steering wheel and so on. So that's quite a useful thing you can do. And the final way of moving things around in this panel is move points, and this works in exactly the same way as mechanisms. So here we've got an H point here, and you can specify to move it to a particular position, or you can specify to move it by a delta or so on. So it works in exactly the same way. And this is just explaining the difference in the mouse values, because these are maybe not obvious but quite useful. So when dragging the assemblies around in the dummy, the left mouse button is normal dragging, middle mouse button is for dragging with the next assembly down the tree temporarily locked, and then the right mouse button allows freedom of the dragged assembly and its immediate neighbour. Now again, in this panel, none of the changes are applied to your model until you click on Accept. And quite often when you click on Accept, you'll see this panel that pops up, which is telling you that the nodal separation of joints has exceeded what is acceptable in the model. So when you're moving things around, you get node separation between the joints. And so you can click on Autofix here, and Primer will move those back to be coincident, and then you won't get any errors when you run the model in LS-DYNA. So to explain this, one common operation would be to fix the hands and feet position and move the rest and allow the rest of the occupant to move. So here you can see hands and feet are fixed, but you're moving the occupant forward and back, and the legs and arms will bend in an appropriate way. Move points, as I've said, work in exactly the same way as the mechanism panel. So you can specify to move to a particular location, or move by a particular delta as well. And in the same way with the mechanism file, you can save this information out. So you can just write it out to the keyword file. So if you've specified a few positions for your dummy, you can write out your dummy include file, and it will save those positions after star end. Or you can write out a dummy angles file, or a positional file, which is kind of a separate file that you can keep. So perhaps you might be reading your dummy file in and out of different preprocessors, and the post star end data will be lost. You can save that as a separate file that you can read into this panel, and it will automatically apply the positions to your data, to your model, and you can choose whichever one you want. Now this is quite useful. So you can link together a seat and a dummy. So essentially what you do is you specify that the dummy is a slave to the seat, and that means that if you move the seat, the dummy will also move. And you do that with the children within a mechanism definition, so you can specify children. And the panel looks something like this. Essentially all you have to specify is what you're slaving to this particular mechanism. So you specify an assembly. So this is the assembly in my mechanism, and then you specify what you want to slave to it. And that might be another mechanism, or it could be a dummy. So in this case here, I'm specifying a dummy that I'm slaving to it. And then you specify an assembly in that dummy that you want to slave to your mechanism assembly. I'll just show you this in Primer again. So in this model here, I've got a seat, and I've got a dummy, and I've got my pelvis of the dummy linked as a child to the seat. So if I go to Mechanism, Position, I'm in drag assembly mode. If I drag the seat base, hopefully see that along with the seat moving around, the occupant is moving around as well. Okay. Now another thing you can do is respect contact during dragging. So quite often when you're moving an occupant around, you can quite easily introduce initial penetrations to your model. You know, you're moving a foot around and you don't realize that the heel of the foot is sticking through the floor or something like that, or part of the foot is sticking through a pedal. So for each assembly, you can specify that you can specify a part set, and when you're moving the assembly around, Primer will look to see when it gets close to any parts in that part set, and it will behave like a contact, so it will prevent you penetrating the foot into the assembly into those parts. So a classic example here is with the feet. You've got the pedals and you've got the floor. So you can specify a part set which contains the pedals and the floor, and then when you're moving the foot around, when you're getting close to the pedals and the floor, Primer will prevent you from moving that through. So it prevents you from creating initial penetrations in your model. And in exactly the same way, one thing you might want to do is position mechanisms and dummies as part of an automatic batch process. So you can do that. So in Primer, there are various command line commands that you can type in, and these are all available to you if you run Primer in batch mode. And some of the commands available to you are relate to mechanisms and dummy positioning. So in Primer, you do this by typing into this box in the lower left-hand corner with the yellow text. And if I type H in there and enter, it gives you a list of the available commands that you have. And you can see that one of those is position a mechanism by typing in mechanism. So if I type in mechanism, hit enter, and then type H for help again and press enter, I get a list of commands that are available to me for positioning a mechanism. So I can specify to fix assemblies, translate, and so on. Lots of different options that are available to me. So that's only applicable really if you want to create a batch automatic process for positioning things and automatically. Other tools that you can use when positioning dummies is you can import a background image into Primer. So you might want to position your dummy to match that in test, so you can read in a background picture from test and set that as your screen background within Primer. You can then go through a process. You click on this Adjust View to Image button, and what that does is you specify a series of points on the image, and then you click on the appropriate node on the model that is the same point, and once you've specified enough, Primer will match the sort of camera location, the perspective and all that sort of stuff, so that your model matches the view that you see in the photograph. You can then compare to see how close your occupant position is to that in the photograph, and you can make small adjustments. So it's quite useful for moving, making adjustments to your hands and feet and the steering wheel position and so on. Oops. So one other thing you can do is to read in data that you might have from test. So you might have some Faro data, maybe some lines, some points, that sort of thing. You can read in IG's data and use that as a reference for positioning. It's just an example of some IG's data that's been read in. You might have some sort of outline marking lines from points taken, and this is an example of some points that have been taken using a ferrite arm, and you can use that to help position your dummy as well. You have to be a bit careful with this because obviously in real life, in the test, the clothing can bunch and you know, not match up exactly with your finite element model. And a useful thing to do here is if you've got certain reference points on your dummy that you know the location of, you can specify a reference point within your dummy definition. So on top of your H point that you will have, you can specify that and specify what location you want that to be in. So here's an example of a position on the heel. You know what that position is from test, and then you type in the coordinate of what you want, and it Primer will move the foot and the heel point back to that particular point, and the rest of the dummy will go along with it. So it knows as to how the relationship between the foot and the lower leg and upper leg and so on. So within the dummy model, when you look at the connection data, you'll see that there's joints associated and joint stiffnesses associated with these dummy models. So they're all taken into account as well when you're positioning the dummy. Okay, so that's the sort of introduction to the basic tool for positioning a dummy within Primer. So let's say you've positioned a seat, and you've also positioned your dummy in the seat. What you're likely to have is the dummy penetrating into the seat model because your seat foam is not compressed at all and your dummy is positioned at the correct H point. So the next stage would be that you'd want to depenetrate the occupant from the seat by squashing the foam. So there's a tool in Primer called Seat Squash, and this is used for solving this problem. What Primer does is that there's two methods here. So there's a Primer method and a Dyna method. So in both cases, the occupant is moved out of the seat, away from the H point location. And then in the Primer method, Primer pushes the dummy back down, compressing the foam to prevent penetrations. And the Dyna method, Primer will help to create an LS-DYNA model in which a dummy is rigidified and then pushed back down into the seat. And at the end of that, you can import the deformed seat node coordinates back into the model. So this is just a diagram showing the differences between the two methods. So you start with the model with the dummy penetrating the seat. So in the Primer method, so Primer lifts the dummy out of the seat, then pushes it back down into the seat. So the top surface of the seat is depenetrated from the dummy as the dummy moves down. The interior foam nodes are repositioned using a geometric algorithm to spread the strain evenly throughout the foam. And then you can, if you wish, automatically create initial foam reference geometry, which can introduce initial stresses into that foam. So that's the Primer method. The Dyna method, so Primer lifts the dummy out of the seat, and then Primer prepares a model for LS-DYNA analysis. So what it does there is it will rigidify the dummy, and it will create a boundary prescribed motion that will move it back down to its starting point. You then run that model in LS-DYNA, and it will also create automatically a style interface springback card. And what that does, it will create a Dyna in file at the end of the analysis. And the Dyna in file is just a keyword deck containing nodal data and various other bits of data that's produced at the end of the analysis. You can then, in Primer, take your original model and import the data in that Dyna in file. So import the foam updated nodal coordinates, and you can also import initial stresses from that file as well if you want to. So this is just some pictures from an LS-DYNA analysis. So the dummy's moved out, it's rigidified, you've got a boundary prescribed motion. and it's moved back down into its original position. And then you get the Dyna in file that you can import back in. So I mentioned that Primer will create this interface springback card to create this Dyna in file. Now I'm just going to show you the Primer method within Primer. So here I've got a model where I've created a cut section through the model so it's easier to see what's going on. And as you can see, my dummy model penetrates into the seat foam. So I'll go to Safety, Seat Squash. And here I can choose to do various things. So I can squash or I can import. So import is what you would use to import a Dyna in file. But I'm going to squash. So I click on squash. Now I get the choice of doing an LS-DYNA analysis or a simple seat squash using Primer. So I'll do the Primer method here. And basically go through a series of steps defining certain things that Primer's asking you, and that will allow you to set up the squash. So the first thing is to select the parts that define the top surface of the seat. So I've got a part in here which is the seat top surface. So these would be maybe null shells that cover the top surface of the foam. Sorry, I did that wrong. The first thing you choose is the foam part. So let me choose that again. So that's the actual foam solids. Now the next thing I choose is the top surface of the seat. And then the final thing is the bottom surface of the seat. So you need to specify the top surface and the bottom surface so that Primer knows how to apply that geometric algorithm for moving the nodal coordinates of the foam in between. Next, you're asked which components make up the dummy. So because there's a dummy definition in the model here, I can just click on the dummy. And also you need to specify the contact between the dummy and the seat, because Primer will use that when running the iterative process of moving it out and moving it back in to check for penetrations and fix accordingly. So I've got a seat to dummy contact here. So here, the final panel now, you have various options for how you want it to move out. Do you want to create initial foam reference geometry and so on? So I'm just going to specify to move out with each iteration. I'll move up in the Z coordinate by 1 millimeters and click apply. So hopefully now you should be able to see the dummy moving up out of the seat until there's no longer any penetrations between the occupant and the seat, and then it will start moving back down, squashing the seat foam as it moves. So still going, so it moves down until it reaches the original location that the dummy was in, and that's done it now. But as you can see, my foam has now been squashed, so I no longer have any initial penetrations between the occupant and the seat. So what are the advantages and disadvantages of the two different methods? So with the Primer method, the result is really an imprint of the dummy shape on the foam. So you can see it's not as realistic as you would get with sort of the LS-DYNA method. Only the foam is deformed with the Primer method. So if you've got a complex seat where you've got lots of different components within the seat itself, it's probably best to use the LS-DYNA method. There's no initial stresses that can be brought in from a Dyna in file, but you can use initial foam reference geometry if you want to create those initial stresses. But it's pretty quick. It's a pretty quick method of doing it. So if you want to do something quickly, that's the method you can use. So with the LS-DYNA method, which is the more complete method really, The result is a more realistic deformation of the seat. Other parts can deform, but not just the foam, and you can include the initial stresses. It does take longer because obviously you've got to include an LS-DYNA analysis in the time taken, but you know, the dummy itself is rigidified, so the models themselves generally tend to be quite small, and you can usually get them through quite quickly. Okay, so that's seat squash. I'm just going to move on to another method of positioning a dummy, which is a pre-simulation method, and it's called the Dyna method within Primer. So the methods we were looking at positioning a dummy before work in the same way with mechanisms. So all the various assemblies move around as if they are rigid bodies. Okay. The issue with that is when you have larger movements of arms and legs and so on, you can end up with initial penetrations. So how do we cope with this? Well, one way to cope with this is to set up an analysis in LS-DYNA that will position your dummy into the desired end location. And when you do that, Dyna will take into account all the internal contacts, material properties, and so on of the dummy model, and you'll end up with a dummy which doesn't have any initial penetrations, and yeah, so it's very much becoming kind of the standard way of positioning a dummy now. So how does Primer do it? Well, what you do is Primer will create cables, and loading in those cables to pull the dummy into position during a Dyna analysis. So then you can in the same way with the Dyna method seat squash, you get a Dyna in file at the end, and then you can import the coordinates and initial stresses into the original model and end up with a model without any penetrations. Now, you have to specify, to start with, you have to specify your target position. Okay, you have to specify where you want the dummy to end up. And you do that in the same way as I showed earlier. So you use the normal dummy positioning method, dragging assemblies around, using points and so on. And then you save that as a saved position. And then that is your target position. Okay. Once you've done that, you go into Safety, Dummies, Position, and then you click on the Dyna button. Now the first panel you get will look something like this. So what Primer has to do is it has to create cables attached to all the different assemblies in your model to make sure that your dummy ends up in the right position. So you have to specify 3 nodes per assembly, and those nodes have to be on something rigid or fairly stiff in your assembly. Otherwise they'll start pulling foam apart if you just choose the outer nodes on some of the dummies, then it's just going to start pulling the soft material around. So they have to be on something rigid or stiff. Now that's a lot of nodes to specify, but there is a button which has automatically determined nodes which will look through all the rigid nodes in your assemblies and automatically choose them for you. Now in the latest version of Primer, version 13.1, there's an option on this panel that allows you to consider encrypted materials. So one issue that Primer has when working with the more recent dummy models is that the material data is encrypted. So Primer doesn't really know if something's rigid or not because the material card is encrypted. So there's an option now in this panel where Primer will take into account that there's some rigid materials in the model and use other information other than the material card to work out if something is rigid or not. So it looks at things like the material, the part title, which sometimes says rigid in certain humanetics models. It'll also look at things like cross-references. So if a node is referred to by a constrained rigid body, a constrained extra node, for example, then you know it's rigid, and so on. It's worth noting that these 3 nodes that you choose per assembly, if you write the model out after choosing them, they are saved in the dummy tree after star end, so you don't have to specify them again. Now this is something else you can specify per assembly. So you can, there's a little R button next to each assembly, and here you use this to specify if you want to rigidify a particular assembly for the analysis. Okay, and this is advisable for things like hands and feet, because if you think about a dummy model's hands, a lot of the fingers and so on are just soft foam, and when you start pulling the dummy around within Dyna, the fingers can be left behind and really deformed. So some things you want to rigidify. So if you click on the R button here, Primer will rigidify those, and they'll move appropriately in the analysis. And when you click on that R button, Primer will recalculate the 3 nodes that it's going to attach the cables to, because now all the nodes in that particular assembly will be rigid. The next thing you specify is you select a node at the base of the dummy's neck and a node at the hip, and this is just used as reference points combined with the H point, so that before the analysis, Primer will move the dummy into roughly the right position globally, so it minimizes the amount of movement that's required actually within the analysis. So you don't spend a lot of time just watching a dummy fly through space trying to get into a final position. And so at this point you specify your target position, and that's one of your saved positions. Finally, you get a panel where you can specify certain values, so the forces that are used in the cables, any damping that's used in the cables, and so on. These are preset to some defaults, and it's advisable just to use the defaults to start with and see how your analysis goes. You might want to tweak these later on. And then the analysis is created. So Primer will create, you can see in this picture, here's a dummy model, we can see all these cables and dampers that have been created attached to all the various different points on the assemblies that will pull the dummy into the final position. So I just want to show you this in Primer because it is useful to go through the steps. So this is a model I've got ready, and I've saved a target position already in here. So you go to Safety, Dummies, Position, Dyna. So this is the panel where you specify the 3 nodes. I'm just going to use and here's this option, Consider Encrypted Materials. So if you turn that on when you're working with a dummy model which has got encrypted materials, then it'll work quite well. So I'll click on the Automatically Determine Nodes button. So Primer is now looping through all the assemblies, looking for appropriate nodes, and there we go, it's populated that panel. And let's say I want to rigidify the hands and the feet. Okay, click Next. Select node at the base of dummy's neck. So if I pick a node down there somewhere, and then pick a node on the left or right hips or somewhere there, will be fine. Now I choose my desired final position, so I've only got one saved position in this model. So if I click on that, you see the dummy moves to that position, so you can see what you're looking at. Excuse me. Back Primer, and then I can change my force values if I want to. So I click Apply. Okay, so when I clicked Apply there, what Primer's done a number of things. One, it's rigidified the hands and feet. 2, it's globally moved the occupant to roughly the final position by using the H point and the node specified on the top of the base of the neck and the one on the hip. And it's also created the cables and dampers that will be used to pull this occupant into the final position. And what you'll find, because Primer's done that initial global movement, is it will generally be the arms and legs and feet and hands that's going to move into the final position. There's going to be minimal movement in terms of the pelvis, thorax, and head as well. And then this is just an output from analysis that is moving an occupant into the final position. So you can see the cables are just shortening until they have 0 length. At the end of the analysis, the dummy will be in the final position that you want. Now the downside, obviously, to using this method is that you have to run a Dyna analysis, which can take some time, because usually to get this to run over a reasonable amount of time, it has to run over 200, 300 milliseconds. But as you can see, it solves the problem of getting initial penetration. So you can see there with this cut section through the pelvis, you can see that all the leg foam parts are reacting against each other. The more rigid parts of the dummy are squashing the seat foam that surrounds them and so on, the dummy foam around them and so on. This is another cut section through the legs. You can see these legs are moving apart, and all the contacts within the dummy are working within LS-DYNA, so you end up with something that is correct in the end. And in the same way with seat squash, you can then import all this information, the updated coordinates, back into your original model, and you'll end up with a position dummy without any penetrations. Yeah, so this is how you do that. So you go to Safety, Dummies, Position, Dyna, and then Import, and that allows you to import that Dyna in file. Now that's it in terms of occupant position. I just wanted to touch on airbag folding at the end here, just because there are tools in Primer for doing basic airbag folding. So normally you'd get an airbag from a supplier, but if you want to create your own airbags or fold an airbag yourself, you have tools to do that. So there's different things you can do. So one is the tool for automatically creating a star or circular type folded bag in 3 steps. So you can very easily create a simple airbag model. The second one is to fold an existing mesh using Primer's step-by-step functions. And in this case, the fold lines have to be predefined. The more useful method is to use Primer's mesh-free function to fold an existing airbag shape, or to automatically create a circular airbag. So with this method, this allows any airbag shape to be folded in any pattern, and Primer takes care of creating fold lines and aligning the mesh and so on. So an example of this. So this, on the left hand side here, we're looking at the unfolded bag. On the right hand side, we're looking at the unfolded bag as well. But so on the right hand side here, you can see the various folds being introduced. On the left hand side, you can see the mesh that you end up with in terms of Primer splitting the mesh and creating new parts and so on. And it's a pretty quick method for very quickly creating a folded airbag. Okay, so that has brought me to the end of the sort of introduction to occupants and positioning and seats and so on. Thank you very much for listening.